So you'll notice that the title of the stream today is a little interesting, but I'll be explaining that. So I'll get right into it. So the first topic that I'll be talking about today is the Dozenal number system. Now, some of you may be wondering what the Dozenal number system is. Well, you're in the right place. And some of you might not care, but I'm going to keep talking anyway. Alright, so basically, the Dozenal number system is, the number system that we use in any everyday situation currently in the world is the decimal system, which is a base 10 number system. It is when we get to 10, that's when we start seeing a second digit. So when you see the number 10, that is equivalent to the quantity of 10. And basically, with the Dozenal system, or in some cases called the duodecimal system, basically what the Dozenal system is a base 12 number system. Now, you may be wondering why is this relevant? Well, there actually is a large group of people that have, for many years, in fact, well into the 1900s and even before that, that have been pushing for a change to a base 12 system. And you may see some aspects of that, and you can see how we have maybe a dozen eggs or 12 months in a calendar. But there are some reasons why a 12-base number system would be more beneficial to an everyday life situation. So basically, what is special about the number 12 is that it is the smallest number with an abundant amount of factors. So basically, if you think about the number of factors, so factors are the numbers that can be multiplied together to get a larger number. And so when we think of the number 10, those factors are 1 and 10 and 2 and 5. That's just 4 factors. But if you think of the number 12, then the factors are significantly more. You have 1 and 12, 2 and 6, 3 and 4. And the benefits of having this is when it comes to small everyday calculations like addition, multiplication, and division, the base 12 number system causes, it makes it a little bit easier to, 1, memorize multiplication tables, and 2, to divide things into fractions, and I'll talk a little bit more on each of those. So first, with the multiplication tables, you will see that if you multiply a number in the base, okay, first off I should explain how the base 12 number system works. So I'm going to pull up a paint here. Okay, so basically in the regular decimal system you have 9 digits. You have, well, 10 digits if you, so you have 0, you have 1, you have 2, you have 3, you have 4, that is not a 4, 4, you have 5, 6, 7, 8, and 9. And these digits are used to create every number in the decimal system. We'll get rid of that one a little bit more. So, and what happens is when you reach the base number, which in the decimal system is 10, you go to a second digit, which is why 10 is 10. Now, in the Dozenal system, the base number is 12. So you may be wondering, how can someone get to the number 12 only having these digits? Well, the answer is to add more digits. So in the Dozenal system, there are 2 more digits. Those digits are dec and L, and the L is a squiggly E thing. And these digits make up the quantities for 10 and 11. And you may think that having more digits is more complicated, and in some senses it is, but I'll explain that the Dozenal system kind of makes up for that when it comes to multiplication and division. So yeah, we have these new numbers here, and so what happens is, just like how you would use a 1, 2, 3 through 9, you can put these in the first place here. So let's say you have the number which has the digits 1 dec, then that would be 12 plus 10, so that would be 22. But in terms of Dozenal, you wouldn't think of it in terms of decimal. That's just a translation. Okay, so what happens when we look at a multiplication table even in decimal, you'll see that eventually, if you keep multiplying something over and over and over again, then you will see that every single number creates a pattern. So let's say you had 1 times 1, well obviously that's going to be 1, so that's a bad example. But let's say you have maybe the 4 tables. So you have 4, you have 8, you have 12, you have 16, you have 20, and then you have 24. So that is how the pattern restarts, and it keeps going. But the problem with the decimal system is that these patterns are only evident in a couple different numbers. I mean, every single number has a pattern, but some of the patterns are very strung out. And what happens with the Dozenal system, because of its many different factors, is that the Dozenal system actually creates a number table and a multiplication table that has very easy to learn patterns throughout most of these digits here. So if you and I can you can look up a multiplication table and see this is true. I don't have one readily available, but if you think, for instance, the 4s, like we said, then you would still have 4, you would still have 8, but then it would simply go to 0, because the next number would be in decimal, it would be 12, but since that's the base number, you would have a 1 and then a 0. So that makes even the multiplication table in the decimal system that was easy even easier, because now the only possible digits you can get by multiplying something by 4 are to end the number. So the only digit you can get in this spot right here is either a 0, a 4, or an 8. And this happens in almost all of these digits. So there are some exceptions. 7 tends to be a little radical, but like I said, all of the digits do have a pattern. And this doesn't just apply to a number table for just one number. You can think of it in terms of the squares of numbers. Now, you may not have thought about this, but when you square a number, even in decimal, there is only a finite amount of digits that can be this last digit here for a squared number. So if you have, so let's just go through some. You start with 0, because 0 times 0 is still 0. Then 1 times 1 is 1. 4 times 1 times 1 is 1, 2 times 2 is 4, so you have 0, 1, 4, and then it goes 9, 6 for 16, and then 5, and then 6 again, and then it comes back to 9, and back to 4, and back to 1, and then back to 0 at 100. And this pattern goes up and back down throughout the rest of the digits, throughout the rest of the squares. And what happens in the Dozenal system is this number, this pattern is decreased to simply 0, 1, 4, 9, 4, 1, 0. Now, if you want to go out and do the math, you can, but you can take my word for it. So this would make the process of squaring numbers a lot simpler and could actually have applications in computer programming, like I have going on here. But I'm not currently applying that. But also, like I said, in terms of division, you will see that it is a lot easier to divide a number in the Dozenal system, especially in low numbers, which are numbers that you would use in every day. So let's say you have a number like 1/3, and that's 1 over 3. Well, in base 10, this would go out to a decimal of 0.3 repeated, or infinite 3's after the decimal. But in the Dozenal system, this is simply 0.4. And you may think that that is a higher number, but in terms of a fraction, that is the same quantity, because it is 4 over the base number, which is 10. But since 10 is 12 in this case, then you get a number that comes out to the equivalent of 1/3. And this is true for many of the smaller fractions, and would also apply to larger fractions as they are factorable. So it is interesting that so what happens with the Dozenal system, and why some people are pushing, and probably to no avail, for people to use base 12 more often, is because in complex math it changes nothing. So when it comes to calculating pi, it's still going to be an irrational number of digits that just keep on going. Now you may say, you will see that it is a different number, like you can see how this decimal is different from this is not a decimal because decimal is base 10, but you can see how the fractional number is different in the Dozenal system. But when it comes to using things in everyday life, because of the ease of multiplication using the patterns of the multiplication tables, it's easier for things like making fractions of groceries, or in terms of how I said before, you can get a dozen eggs. Well, if you just wanted a quarter dozen, if there were only 10 eggs, then you would have to get 2.5 eggs, and that wouldn't make sense. But if you want a quarter dozen of a dozen eggs, which is what normally happens, is there's 12, then you can get 3 eggs. So and also with how easy it is to memorize the multiplication table, it makes it a little easier for kids who maybe just don't get math at all to memorize these tables, so that they can get by with the simple maybe making of change and things like that. So, like I said, with how intertwined the decimal system is into our society, I don't see this ever being actually applied as a societal thing, but it is possible that this could be applied in a more abstract way, possibly with computer programming to calculate things in a more efficient manner. And with that, I will be moving on to the next topic, but in the meantime, I'm going to play a short ad. So I will be right back.